Welcome to G Fun Facts Online, where we dive into the science that's shaping our future. Today we're talking about something straight out of science fiction: materials that can think, remember, and change their shape on command. Imagine an airplane that could morph its wings mid-flight, or a satellite that unfurls in space like a blooming flower. This isn't a dream. It's the reality of a new technology called Shape-Memory Composites. So how does a material have a memory? At its core is the shape-memory effect. Picture this. You take an object, you bend it, twist it, or fold it into a completely new shape. Then, with a specific trigger, like a bit of heat, it magically springs back to its original programmed form. This works because the material has two states at a molecular level: a permanent, memorized state and a temporary, deformable state. The first materials to do this were metals, called shape-memory alloys. When you heat them, their crystals rearrange, and they snap back to their original shape. Super cool, but these alloys are heavy and can be a bit unstable over time, not ideal for sending things into space. That's where the real game changer comes in: Shape-Memory Polymers, or SMPs, discovered in the 1980s. These are lightweight, can be deformed much more, and are cheaper to produce. The trigger for these polymers is usually temperature. When you heat them past a certain point, called the glass transition temperature, they go from a hard, glassy state to a soft, rubbery one, allowing them to snap back to their memorized shape. But polymers on their own aren't always strong enough for the intense demands of aerospace. This is where the composite part of shape-memory composites becomes so important. To beef them up, engineers embed reinforcing materials, like super-strong carbon fibers, into the polymer matrix. This gives you the best of both worlds: the lightweight, shape-changing ability of the polymer, plus the strength and stiffness of the reinforcement. It's a material that's both smart and strong. Now, how do you activate this transformation? While heat is the classic trigger, scientists are getting incredibly creative. They're making composites that respond to an electric current by adding conductive fillers like carbon nanotubes. This allows for super fast and precise shape changes. Others respond to magnetic fields, which means you can activate them remotely without any contact. There are even composites that react to specific wavelengths of light. The applications for this in aerospace are mind-blowing. Let's talk about morphing wings. Instead of separate flaps and ailerons, an entire wing could change its curvature to be perfectly optimized for takeoff, cruising at high altitude, and landing. This means better aerodynamics, less fuel consumption, and more maneuverability. Then there's space. Getting large structures like antennas and solar panels into orbit is a huge challenge. You have to fold them up into a tiny package for launch. With shape-memory composites, these structures can be packed down, and then once in space, the heat from the sun can trigger them to deploy into their full functional size, all without complex, heavy motors and hinges. This technology is still facing challenges, of course. Space is a harsh environment, with extreme temperatures that can affect how these materials perform. Scientists are working hard to improve their durability and fatigue life. But the future is incredibly bright. We're heading towards multifunctional composites that can not only change shape, but also heal themselves if they get damaged, or even sense their own condition. From self-deploying space stations to self-repairing aircraft, shape-memory composites are fundamentally changing what's possible in the sky and beyond. Thanks for tuning in to G Fun Facts Online. Join us next time as we explore another amazing piece of our universe.